Oxidation and reduction play an important role in many of the chemical reactions. Therefore, today we shall take up and learn a few concepts about how to identify oxidizing and reducing agents. And this we shall go through a chemical reaction which is given in PYQ and has appeared in various competitive examinations earlier. So let us view the question. It's an important JEE advanced PYQ. The question is here. Hydrogen peroxide in its reaction with KiO4 and NH2OH respectively is acting as a, four options are given. They are required to find out which is a reducing agent, which is an oxidizing agent out of these. And now, what is most important initially is to know what is KiO4. KiO4 is known as potassium periodate. And what is NH2OH? NH2OH is known as hydroxylamine. These are the two important compounds which are allowed to react with hydrogen peroxide. Now, there is a typical characteristic of hydrogen peroxide. It acts as a reducing agent as well as an oxidizing agent. Oxidizing action occurs according to this equation, where it reacts with two electrons, takes up two electrons and is converted to water. Similarly, reducing action, it gives up two electrons to the oxidizing agent. So that's there. And then before we get into anything, it is very important that we know that what is oxidation and what is reduction. There are many ways to get oxidation and reduction. For example, the addition of oxygen, removal of oxygen, oxidation, reduction. In terms of hydrogen also we have an idea, and loss or gain of the electron. So this is just a revision. We need to go through it and then we shall decide which will be the best method to find out oxidation and reduction here, so far as hydrogen peroxide is there. Now, here it is the oxidation state. Increase in oxidation state is oxidation, and decrease in oxidation state is reduction. So far as these reactions are concerned with potassium iodide and hydrogen peroxide, or with the hydroxylamine and hydrogen peroxide, the variation or change in oxidation state should be determined. Now let us go through the reaction, how KiO4 will react with hydrogen peroxide. KiO4 is known as potassium periodate, and here we find that it is in the highest oxidation state, potassium periodate. Iodine is in the highest oxidation state in potassium periodate. It is +7, and with hydrogen peroxide, it gets converted to potassium iodate, KiO3, where the oxidation state of iodine is +5. That means there is a decrease in oxidation number. +7 is converted to +5 during the course of the reaction. So what has happened? That hydrogen peroxide has acted as a reducing agent, and potassium periodate is reduced to potassium iodate. This way, so far as the calculations of these oxidation states are concerned, it is given here. Potassium 1, because it is having a positive charge. Let iodine, the oxidation number of iodine, I be represented by X, and oxygen is always -2. Of course, in certain cases, and a few cases there where it can be +1. So anyway, we calculate this way the oxidation number of iodine in potassium periodate. Similarly, we calculate the oxidation number of iodine in potassium iodate as given here. So that's the situation. And here we find that H2O2, that is hydrogen peroxide, has acted as a reducing agent. Now let us take up the other reaction where NH2OH is oxidized to N2O3 by H2O2. NH2OH, is hydrogen hydroxylamine, and the reaction takes place. N2O3 is formed, and if you look at the oxidation state the same way as we have done earlier in case of potassium periodate, same way we need to calculate the oxidation state of nitrogen here, which is -1, and here the oxidation state of nitrogen is +3. So that way we calculate and we find what has happened here. And oxidation has taken place because the oxidation state has increased from -1 to +3. Now, how to calculate oxidation state is provided here, and it's very easy to learn how to find out the oxidation state of nitrogen as -1 here. Similarly, the oxidation state of nitrogen in N2O3 is calculated this way. So we find that the oxidation state of nitrogen in hydroxylamine has changed from -1 to +3. That means there is an increase. So increase in oxidation number is NH2OH is oxidized. Now, with all these concepts, we finally get that H2O2 acts as an oxidizing agent here. In the second case, therefore, so far as our question is concerned, hydrogen peroxide in reaction with KiO4 and NH2OH respectively is acting as a reducing agent and oxidizing agent. Option A is definitely therefore correct. The other options B, C, and D are not correct and can be ignored so far as the answers are concerned. Okay, thank you very much. We should be back again with some more questions later on. But thank you. Please do subscribe to our channel. Thank you very much again.